Let's take a look at problem O. So as you may have noticed, problem O is similar to some of the recent ones that you've done in that it's kind of a trick question as well. Primarily because the language here states a blanket case. This states a very general proposition which is actually false. At least the way that it's stated. And so it says, prove that no triangle ABD, so in this case, ABD, having side AD on the diameter and point D not at the center, can be an isosceles triangle. Now, this is not true because this would actually be impossible to prove. And so if you proved that this was impossible, then that's okay. That's a perfectly legitimate way to approach this problem, is by showing that this actually can't be proven as stated. So if you did that, good for you. That was fine. But we can actually adjust this slightly and write a valid proof. And so the reason that you can't actually prove it as it's stated is that it's always possible for side BA to be equal to side AD. Right? And if you can imagine drawing a circle with center A and radius AD, you know that this would produce a triangle ABD such that side DA would be equal to side AB. So then we would in fact have an isosceles triangle inside this circle where one of the sides lies on the diameter and that corner D is not on the center. However, if we want to try to prove it as closely to the language as we can, or at least keeping the language as close as we can to the original enunciation here, we just have to add this clause, so long as BA is not equal to AD. So now we have delimited this, right, to those cases where BA is not equal to AD. So anytime BA is not equal to AD, then we can prove that this cannot be an isosceles triangle because the remaining side, BD, cannot be the same length as AD. So that's really what we're going to prove here. I've written two proofs for it, and you'll see why in just a minute. So first, we say let circle ABC be drawn with center E and let it contain triangle ABD, such that D lies on the diameter. I say that side BD is unequal to DA. So BD we're saying is unequal to DA. That's the main claim here. 4. Because side DA lies on the diameter and BD does not, DA is therefore greater than BD. How do we know this? Well, we know this from the proposition that we just looked at, which is proposition 7 from book 3. And you'll remember that the proof basically runs like this, referring to proposition 120. We know that any two sides of a triangle taken together are greater than the third side. And so if you imagine drawing line EB in here, you know that BE plus ED is going to be greater than side BD. But BE is also the same length as AD because they're both radii of the same circle. So if we add the same length, ED to each, then AD is equal to BE ED, and therefore AD is also greater than BD. That's the reasoning employed by 3.7. Thus, we can conclude triangle ABD is not an isosceles triangle because it has unequal sides, namely AD and BD. And again, I've just repeated this so long as BA does not equal AD. So assuming, again, that this side, BA, cannot or is not equal to AD, then the proof holds up. Now, the reason I've written a second proof is because it's possible to draw this figure in a different way, and it changes how we prove it very slightly, but it does still make a difference. And so, if we imagine, then, this case instead, we have a diagram that looks like this. And so the difference here is that J, which of course corresponds to point D, is on the same side of the diameter as point F. Because before, remember, this point was over here on the opposite side of the center. Now they're on the same side of the center, and it changes the way that we write the proof a little bit. But it's still, we're still relying on proposition 3-7, and that's key. So to prove this, we write something like this. For let circle FGH. So here's our circle FGH. Be drawn with center K, and let it contain triangle FGJ. So here's our triangle FGJ, such that J lies on the diameter. I say that JF is unequal to GJ. So that's the claim. So JF is still unequal. Now, in the previous case, we saw that the side on the diameter is actually longer than the side not on the diameter. But in this case, it's going to be shorter, right? JF is going to be shorter than GJ. Because JF lies on the diameter and JG does not, JG is going to be greater than JF because JG is nearer the straight line through the center. And that, of course, is JH. So if you remember, sort of taking this line, and if you imagine this point as being like a rubber band or something, and we're just dragging point G along here, as we get closer to point H, JG will get longer and longer and longer until it's equal to JH. And as we approach in the same direction as we approach point F, it'll get shorter and shorter and shorter until it is equal to JF. And so JF is the shortest length that we can get here, and JH is the longest length. Right, and so that means, of course, that JG is going to be greater than JF. And we know this, again, from proposition 3-7. And that's all that we really have to say. Proposition 3-7 proves this case as well. And so then, triangle ABD is not an isosceles triangle having unequal sides, right? And again, we have to state so long as GF does not equal JF, and so this is pretty much the same as we saw before. But that's really all that it takes to prove problem O. Now you could have started with this diagram and produced something, produced an argument which essentially repeated in detail the argument given by 3-7, and that would have been appropriate, right? So you could have actually written out the same line of reasoning as Euclid employs in proposition 3-7, and that's perfectly fine. However, just referencing 3-7 and using it in the proof like we've done here does allow the proof to be considerably shorter than it would be otherwise. And again, as always, be on the lookout with these problems for things that at first glance may not have anything wrong with them, but upon closer inspection actually do present impossible cases, or at least cases where the language is not sufficiently precise. Because you want to get into the habit of thinking very, very carefully and very precisely about the way that things are worded. Does the wording of a particular enunciation actually allow for things that were not intended? And the more and more attention you're able to pay to these kinds of things, the better you will get at writing really great proofs.